Hey, this is Adam Wise, application scientist at Andor in the US, and today I'm going to show you some of the intricacies of timing and triggering with an iXon 897 Life camera. This is an EMCCD, and I'm going to show you how triggering and exposure work a little bit more intricately than you might be used to. So first things first, let me show you how to set up an acquisition. This is our Solace control software. This is an oscilloscope I have hooked up, and this is showing my trigger right here, which is coming from an Arduino. So let me start by setting up an acquisition here and configuring it. I'm going to set up a kinetic series, which is a movie basically, and I'm going to start by internal triggering. Internal triggering just means the camera runs the show. So I'm going to start the acquisition just by clicking a button, and then the camera will decide how to do the timing. And I can see I have a kinetic series cycle time where for a 50 millisecond exposure, say, it's going to take about 107 milliseconds to capture a frame and then move on to the next one. And this is without frame transfer on. I'll talk about what that means in a minute. And then this is without cosmic ray removal, and I'll talk probably about that in a minute as well. And then the rest of the acquisition settings are here in terms of EM gain, readout speed, and so on. I'm not going to worry too much about that. I'm not worried about my image quality right now. I just want to show you timings. So what is internal triggering going to do? When I hit acquire, the exposure just happens, and you can see it's not at all in sync with my trigger. It's just happening on the schedule of the camera. The camera's clock tells it that it's finished an exposure or it's finished a readout, and it goes on to the next one. And you can see the space in between exposures is quite long, and that's because we don't have the frame transfer mode activated right now. So let me just show you qualitatively what happens when we turn the frame transfer mode on. You can see my speed has gone up quite a bit. My kinetic cycle time has gone down quite a bit. I can kind of flip that, and you can see my exposure time is 50 milliseconds, and my kinetic cycle time is just about 50 milliseconds. So my readout time, which is that additional overhead, seems to have gone away, and I'll confirm that in the oscilloscope. So you can see my fire pulses are basically overlapping. The red signal is the fire monitor from the camera. That means exposure. And I don't really have any dead time, which is great. So let me just show you real quick in the hardware guide what the difference is there. So this is what the chip looks like kind of qualitatively. There's an image section up here, and then a storage section which is under a mask down here. So we can take an image. This is the part that's actually exposed to light. It collects photons that end up as electrons. When we're done with our exposure, they get sent down to the storage section and then shifted down independently into the readout register, one line at a time. If we don't have frame transfer mode enabled, what happens is that we collect an image. Once our exposure time is over, it gets shifted down here, and then slowly read out one line at a time, or quickly read out depending on the acquisition settings, but relatively quickly read out. Then once we've read out the entire image, we start the cycle again and collect more light in our imaging area, send it down, and then so on. If we enable frame transfer, what happens is this. We collect light, we send it down into the storage section. Now, while this is reading out, we collect our next frame. So we're actually kind of doing this in kind of like duplex mode, if you'd like. We're using both sides of the chip. This is going to be a buffer for readout. This is going to collect the next frame, and we can pump these frames through quite quickly. So we don't really have any dead time for the most part. And let me switch back to here. Now, if I want to sync these frames with some trigger, I want to collect light from some phenomenon that I'm keeping track of, what I can do is this. If I simply want to define a start time from an external trigger, I can go to external start. And what that will do is start the series based on when it gets the first trigger. So I hit OK, I acquire again, and now when I hit this button, the camera will wait for the first trigger coming to it. And maybe what I'll do is I'll disconnect the power from my trigger generator, and I'll say, OK, let's wait. Now this camera will wait, ready to pounce on the first frame, or the first trigger that comes to it. So I'm going to plug my function generator back in, or start it up again. And in a second, it should get a trigger. And I'll see a little LED start. Oh, and now it's collecting frames. However, those individual frames are not synced to anything. Only the start was synced. And then the rest will just happen as quickly as possible on the internal clock of the camera. Now, what if I want to sync each frame to some external trigger? Well, now I can do something like this. If I go to acquisition setup and I set it to external, so this is external triggering. Now what's going to happen is that each frame is started by a trigger. So I need one trigger per frame. You'll notice here it says exposure time equals trigger period. I have frame transfer enabled. If you can imagine, if I go back to this diagram, now what's going to happen is I say trigger. Okay, that means start exposing. When I get the next trigger, it will launch the image down into the storage section and begin exposing the next frame. And you can understand why that will mean the exposure time is really the trigger period, because there's no real additional space in between those two steps for something else. As soon as I shift that down, it's ready for the next exposure. It's collecting the next exposure already. And let's see what that means in terms of synchronization here. Okay. And so now you can see that the exposure time, as each cycle goes, the exposure is here linked to the trigger. And nominally my exposure is whatever I set it to, 50 milliseconds. But I mean, really, I'm collecting light until the next trigger happens. There's something I do want to show, though, that's a little bit of an intricacy. And you're probably going to learn more than you wanted to necessarily even know about, pardon my dogs there, about the triggering and the timing here. So let's take a closer look at that first frame. And you can see here that this exposure is happening quite promptly after the trigger goes. I can zoom in there, but let's see if we can catch what happens in the first frame. No, let's zoom out a little bit in time, or maybe zoom in a little bit in time, and let's see if we can catch it. Ah, there we go. And just in case you missed that, I'm going to zoom in, and you can see the first frame is actually delayed by quite a bit relative to subsequent frames. Why is that? Because I believe we have a keep clean cycle happening, and what this means is that at the beginning of the sequence of exposures. So let's go to here. The camera is set to wait for a trigger. So I'm beginning my measurement. So the camera says, okay, I'm waiting for a trigger. It could be waiting for a week. The camera doesn't mind. And if my phenomenon isn't happening for that time, until that time, it'll just patiently wait for that trigger. When it does get the trigger, what it will do is say, oh, this place is a mess. There's an extraneous charge everywhere, either thermally generated, which is pretty slow, or it could be stray light or whatever, left over from the last exposure. And what it will do is it will sweep that charge out of this part of the sensor. And it does that by vertically and horizontally shifting it out. But then once that is finished, and then it goes to the next frame, then subsequent frames don't have a keep clean cycle, because as I mentioned, it's pretty tightly coupled in between your exposure, then you're shifting that down into this area, and then you're doing your next one. So there's not really a lot of room for additional cleanout cycles, nor necessarily might you want them. After that first one, things should be happening pretty quickly. So let me go back here, and you can see that the actual gap in between the exposure and the trigger and the fire signal is pretty small. It's on the order of, I think, on my measurement here, a couple hundred nanoseconds perhaps. But again, I'm not sure how much I trust that level of precision on this oscilloscope that cost me $100 or something like that. And I'm sorry, Picoscope guys, if the actual specs are better than that. I'm just saying I would use it as a little bit qualitative of a measurement there. So it's relatively prompt, at least compared to the first frame. So the other thing that I can show is, so here, let's see, I just wanted to show real quick. If I zoom back out, you can see my, zoom all the way out. And I have to get to it where I can see multiple milliseconds on the same frame. You can see my trigger is yay wide, my exposure is yay wide, and because of that, I'm actually collecting outside of that range, but it's linked to the number that I put in here and what the exposure should be, about 50 milliseconds. So what I can do is switch to a different mode if I want to actually define formally my acquisition time, or my exposure time, just from the trigger pulse. What I can do is use the external exposure mode. and this had a flash bulb, I think, at one point that showed sort of what it was doing, but you can see that the frame transfer info has gone away. So I can only do this in non-frame transfer mode. And let me go and see what the timing consequences of that are. So you can see it is quite prompt, and the exposure time is matched to the trigger. So if I were to change that trigger, and I'm going to do that real quick by changing my Arduino sketch, now you can see it's actually matched pretty well there. And there's no lag on the first frame, I believe. Let me zoom out there and take an image. It's just ready to go. There's no cleaning cycles involved. So this is a very prompt mode. Well, I should say that there's a very minimal cleaning cycle involved, I believe, but not with the same one, not with the same length as a normal clean out cycle. And one other thing in this video, I might record a couple more parts to this, and you can see further on, is the jitter involved in the keep clean cycle. So if I were to go back to, let's say, let's see, external triggering, we're going to use frame transfer mode. We're going to use non-frame transfer mode. And you can see that there is an indeterminacy in when that exposure actually starts. And I'll have to double check myself on this one, but this is why you can occasionally get in trouble with doing expecting a very prompt trigger on the CCD, in that if the keep clean cycle is enabled, and if you aren't 100% sure how long it's going to take, there can be some issues when you're trying to catch a very fast signal, or at least one that you think you should be able to catch that's quite fast. But there could be some indeterminacy about when the exposure actually starts, when the cleaning cycle actually ends. If you're not using a cleaning cycle, and we have options for, depending on the camera, for not using that, and oftentimes that's not a problem if you have the light exposure under control through other means, shutters and so on. And we're not really worried about building up thermal charge over some long wait, dark counts I should say, over some long wait, then you can usually do without it. But the thing is that exposure to exposure, we don't know exactly in this case when, relative to our trigger, the actual exposure starts. So it's fine if we're monitoring the fire signal to actually catch when the exposure starts. But if we're saying, okay, I'm gonna expect that my camera will come online at some extremely tight tolerance after the external trigger comes in, then you can be caught unawares by that. And I think I'm gonna keep this video to a reasonable length, and then probably come back to talk more about some things a bit more detail in a second part of this video. But for now, I think that's it. And if you have questions, feel free to send me an email at a.wise@andor.com. Or visit the Andor website for more information. And other than that, have a good day, or potentially a good week, depending on when you're listening to this. And I'll talk to you later.